Hey guys, this is Sasha the guy. Today I wanted to show you how to use our TinyBio chat for single-cell RNA sequencing quality QA with Seurat. And so TinyBio is a chat program, and so you can use it how you would typically interact with any chatbot. So you can start by just asking a question: how do I do QC single-cell RNA-seq data using Seurat? Now, Seurat is a very popular analysis package for single-cell RNA sequencing, and TinyBio has access to all the documentation for it. And what it's doing right now is that it is building, and explaining to you line by line exactly how to do QA with Seurat. So most importantly, after the import and installation, it also tells you how to visualize the QC metrics. So before filtering, it's important to visualize QC metrics to determine the thresholds for filtering. Common metrics include the number of detected genes per cell, the total number of molecules per cell, and the percentage of mitochondrial gene content. So you can see all of this here. The filtering out of the lower quality cells, so based on QC metrics, you can lower those out. So you can say, hey, if there's too many genes, or too much mitochondrial content, you can replace those. And finally, you can normalize the data so that way it is comparable across several different samples. Once you do that, you kind of get this nice Seurat object, which is scaled, and that you can then visualize for your PCA, your UMAP, your TSNE, things like that. If you want all of this in one file, you can also ask TinyBio to do that. So you can say, hey, can you write this for me into one file? And so right now what it's going to do is it's going to write an R script of Seurat that is going to just do everything that you'll need for your QC using Seurat. And so it's going to do all the same things. So it's going to load the Seurat package, load your single-cell RNA sequence data into a Seurat object, calculate the percentage of mitochondrial gene content, visualize the QC metrics, replace low-quality cells based on QC metrics, normalize the data, find highly variable features, scale the data, and then finally save your Seurat file. But now let's say that we don't know exactly what percentage of upper bound and lower bound genes and max percentage mitochondrial content to use. So we'll say, hey, can you look up a single cell RNA-seq review and find out what are the best values to use for lower bound genes, upper bound genes, and max percent mitochondria. So what TinyBio is going to do right now is that it's going to look at its PubMed store and it's going to find some reviews on single-cell RNA sequencing. Now, it's going to read in that information and it's going to provide you some solution to this. So in this case, it's saying, hey, there's no one way to cut it, but it's saying, hey, there's a MyQC package which is used a probabilistic framework to generally model portion of reads map into mitochondrial reads and the number of detected genes. This approach adapts differently types of single cell to remove low quality cells while preserving high quality cells for downstream analysis. Okay, so it looks like it found a library for us to use that can be used for figuring out the exact amount of data to filter out. And then if we're interested, we can go in and take a look more. Thank you guys. Bye-bye.